Hi HPC, this is Trig Notes number 5. This is going to be tying in a few loose ends that we have, so it's going to be a super quick one. We've been talking a little bit about reference angles. We're going to kind of make that officially part of our notes right now, and then we're going to do a couple other cleanup things of helping you find stuff around the unit circle in different quadrants if you're having trouble with that. So let's go. So in the first one, we want to know that the reference angle will always be something that is less than 90 degrees and positive and less than pi over 2 if it's radians and positive. Okay, so reference angles are always positive. Always positive. Because they're basically saying how far is the distance to the x-axis. And by the time I'm at 90, I'm in equal distance from either side. And the second I pass to 91 degrees, it's now actually easier to go to the other side. So let's show you what we mean by that. So we have 120, right? So I know that 120 doesn't make it quite to 180, right? So where is it? Well, it's going to be 60 degrees apart. So it's going to be somewhere right around here. And we know that there's going to be 60 degrees between here and there. So here is the triangle that you would have made. Here is the central angle. We went 120 going this way. So what is our reference angle? It's that central angle of that little triangle right there. That would be 60 degrees reference angle, and it's a quadrant 2. All right, let's try that again with number 2. So in number 2, we have negative 135. That's totally okay. We're still going to just go wherever negative 135 is. Then we're going to find the reference angle. How far is it to the nearest x-axis? So if this is 0 and I go this way, and this is negative 180, and this is negative 90, right? Then 135 is going to make it past 90 and not make it to 180. It's going to be somewhere in quadrant 3. And how far will it be from 180? It will be 45 degrees. So 45 degrees would look like this. The reference angle, though, is going to always be the angle that attaches it to the x-axis. So here is the triangle we would make, here is how we would have gotten there, and then this amount in here is 45 degrees. Kind of makes sense? Okay, let's try a couple more. All right, 60. Well, that's super easy. That's going to be a positive, and it's not going to make it to 90, but it will make it part of the way. So it's going to look like this. Here is my right triangle. Here's my central angle. So this is a quadrant 1 with a 60 degrees because it is exactly 60 degrees to get back to that x-axis where we started. All right, on to the next one, 300 degrees. So in 300 degrees, we've got 0, we've got 180, and then we've got 360. So it's closest to 360. How close? It's 60 degrees away. So 60 degrees away looks something like this, and we are in quadrant 4, and we are 60 degrees away from the closest x-axis. All right, negative 240. So negative 240, we're going to start here, go this way, it's negative 180, go this way, it's negative 360 to come all the way back around. So which one is it closer to? Well, I would have passed 180, and then I would have gone another 60 degrees past. So 60 degrees past doesn't make it up to the next vertical. So this is a 60 degree reference angle. And we're in quadrant 2, 60 degrees from the x-axis. Right? And our last one, 580. So we know to get back to here is 360. To get over to here is 540. That's pretty darn close to 480. So on this one, we would have gone around all the way to here, and then we would have gone another 40 degrees. So another 40 degrees would be right about here, and we'd make a right triangle, and we'd be in quadrant 3. And how far was it that we went past 540? We went 40 degrees past. So our reference angle is a positive 40 degrees. Yay, pretty easy, right? All right, more challenging is when we go into radians because we're dealing in all these fractions. Okay, so that's okay, we'll still do it. So in the first one, let's start this one maybe in green. Okay, so in this one, we're thinking in sixes, right? So this is 0, 6 with a pi. This is 6, 6 with a pi, and I'm going to stop writing the pi because it takes up extra space. And then this is 12, 6. So if I want to go to 5, I didn't even make it across yet. I would have made it about 1/6 of the way. So if you imagine that you were chopping this entire top half into 6 equal pieces, one piece would be about that big. And how far is that reference angle? We're in quadrant 2, and the reference angle is 1/6 pi, right? It's how far it was to get to the end or to the nearest x-axis. All right, let's try the next one. So if we're doing negative pi over 4, this is 0 over 4, this is negative 4 over 4, this is negative 8 over 4. So I definitely would have made it all the way around, right, almost to 8/4, except for 1/4 of a top part. So it'd be right about there. Our triangle would be in quadrant 1, and it would be pi over 4 for this angle right here, and we would have gone around all this way. Okay, so reference angle, how close is it to the nearest x-axis? All right, let's try the next one. 11/3. So this is 0/3, 3/3, 6/3, 9/3, 12/3. Too far. 11 is closest to 12. It's 1/3 away. So if you imagine this entire amount being chopped up into 3 equal pieces, a third would have been right about here. So this is the triangle we're making. This is the angle we're looking for. So we're in quadrant 1, and that angle in radians would still be pi over 3. All right, next one, number 10. Okay, so sevenths, sure. 0/7, 7/7, 14/7. I'm just counting up by whatever the denominator is. So I would have made it past 7, but I wouldn't make it all the way to 14. I'd be about 2/7 away. So again, I'm imagining this entire top half, the semicircle, being chopped into 7 equal parts. And I'm 2 before, so I'm probably like right about here. So here's my triangle, here's my angle. So this is a quadrant 1, and I am 2/7 away from the nearest x-axis. So my reference angle is 2 pi over 7. All right, on to the next one. So negative 5/8, 0/8, 8/8. Don't even have to go further than that, right? So we want to go 5/8. So if I imagine this entire bottom circle cut into equal parts, 4 would have happened right here. We want to go this way 5. So I'd be somewhere right around here. And that's going to give me the central angle right here. This is going to be a quadrant 3. And how far is it away from, if I'm at 5, how far is it away from 8, which is the nearest x-axis? It is 3/8 away from the nearest x-axis. By 5, we've passed that halfway mark. So now we want to see how close is it to that other horizontal on the left-hand side. All right, and our last one, we have negative 8 pi over 3, 0/3, negative 3/3, negative 6/3, negative 9/3. Looks like we're going to be pretty close to negative 9/3, right? So again, we're imagining this entire bottom circle being cut into thirds, and we're at 6/3 when we were over here. So 7/3, 8/3 would be right about here. And that leaves us 1/3 as the central angle. So this is quadrant 3. 1/3 is the angle that gets us to the nearest x-axis. And then the last little thing I want to do is we've been counting around in radians for a while, but there's a really cool way to kind of count around if you're having trouble with that. So I thought I'd start and kind of show you some of those. So like, let's look at one of the pi over 4s. That's one of the ones that would make a 45-45 triangle. And that's going to be one of our important ones pretty soon. So let's start using the force and count around until we get to 2 pi, which we know would be a force. So we're going to start out with a 0, and then a 1, and then a 2, and then a 3, 4, get the idea, 5, 6, 7, and 8. All right, and then the next thing that I want you to do is I want you to cross out anything that reduces to something that you know, like a 0 or 1, right? So let's see, let's go and cross out the 0 goes away, right? 2 over 4 reduces, so cross it out for right now. You'll see why in a second. 4 over 4 reduces, 6 over 4 reduces, 8 over 4 reduces. What's left is going to be one of those 45-degree angles in each one of the quadrants, not on one of the quadrant markers, not on a vertical or a horizontal, but in each one of the quadrants. So what that looks like then is we will end up having this one right here, that is our quadrant 1. We have This one right here, that is our quadrant 2 angle. This one right here is our quadrant 3, and this one is our quadrant 4. So if I look at this right here, and I try to chop it up, right? We already know that the 2 over 4 ended up right here, that this was 0 out of 4, this was 4 out of 4, right? So each one of these gives us this one here, this one here, this one here, and this one right over here. Cool. So what do those look like? This is where your pi over 4 is going to be. This is where 3 pi over 4 is going to be. This is where 5 pi over 4 is going to be. And this is where 7 pi over 4 is going to be. Now, where are all the rest? The ones that we crossed out turn out to be on the x or on the y-axis. So 0 pi over 4 is right here. That was 1. This is 2 pi over 4, and 2 pi over 4 reduces down to pi over 2. So pi over 2 is right here. Next one? 4 out of 4 reduces to just pi. And then 6 over 4 reduces to 3 pi over 2 is right here. And then lastly, we have 2 pi, 0, and 8 work over here. So it's just one of the easy ways to look at stuff is if you can just write them all out in the list and cross out the ones that reduce, those should be the ones that are left so that you only have one in each quadrant. All right, let's try it again with thirds. So pi over 3's turn into 60 degrees, right? So let's go and fill those in next. So starting with 0. 0, 1, 2, 3, right? That's halfway around the circle. Keep going. 4, 5, 6. That's going to be a 2 pi. All right, let's go through and cross out anything that reduces. So 0 reduces, 3 reduces, 6 reduces. So what we'll have left is 1 in each one of the quadrants. So this one will end up being our quadrant 1 answer. This one will end up being our quadrant 2 answer. This will be our quadrant 3 answer. This one will be our quadrant 4 answer. So where are thirds? So again, if I think about that this is 0 thirds pi, but also 6 thirds pi, and that this is 3 thirds pi, right? And I want to look at the top half of this semicircle and look for how could I turn it into thirds. So thirds would be here and here, right? Along with this part here that's already a horizontal. So notice we don't end up using a vertical on this one at all. And then the other one is on the other side and this side right here. So these become 1 pi over 3, 2 pi over 3, 3 pi, 4 pi over 3, 5 pi over 3. Cool. Let's try it one more time with 6's, and those are going to be the last of our main ones that make triangles in each one of the quadrants. And this one is going to be 0 over 6 all the way to 12 over 6. So we'll do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. All right, so we're going to cross out anything that reduces. So this one reduces, this one reduces, this one reduces, 8 over 6, 10 over 6, 12 over 6. All right, so that means we're going to end up with 1 pi over 6 is going to be our quadrant. Couldn't think of the word quadrant 1. And then we're going to have, oh, I missed one. 3 pi over 6 reduces too, doesn't it? And 9 pi over 6 reduces as well. All right, so we're going to have that one. This one is going to be our quadrant 2. This one is going to be our quadrant 3. This one is going to be our quadrant 4. Okay, and then the other thing I wanted to show you as well is some of those that reduce, right? If they're not the whole number ones, so I'm going to purposely cross out this one again, and this one again, and this one again, right? Those are going to be our horizontal line ones. We kind of already know where those are. And then this one has also vertical ones, right? Those are going to be the ones that end up being the pi over 2, or so this one right here turns into pi over 2. And then this one over here turns into 3 pi over 2. Okay, so if I start at these, here is 1/6, here is 5/6, here is 7/6, and then here is 11/6. Cool, so those are our ones that have a reference angle of 30 degrees in each one of the quadrants. Cool, and then we'll go back in and we'll put in the other ones. So this is 0/6 and 12/6. This is 6/6. This one would be 3/6, which is pi over 2. This one would be 3 pi over 2 or 9/6, right? And then there were some other ones that were thirds, right? Some of these just reduced down to thirds. So this would have been a pi over 3, but again, that's not going to be one of our reference triangles for a pi over 6. It's going to be a reference angle for a pi over 3, so it falls under a different one. This one turns into 2 pi over 3. So it's kind of like those missing little thirds if you were to go all the way around. And then this one turns into 4 pi over 3 and 5 pi over 3. And then we're back to the horizontals again. All right, so if we're trying to draw a reference angle in each one of the quadrants that has a pi over 6, that's where they would be. That's where we'd find them. All right, so it would not be a bad idea to cover up all of your prior work and see if you can go around and name each one of those lines as a degree and as a radian. And I'm going to give you a couple seconds here to pause. This would be a good place to pause if you want to actually practice this. So here's what I'm looking at when I do these, is I'm going to go and do the horizontals and the verticals, because I know those are always going to reduce down to 0 pi and 2 pi over here. These are always going to reduce down to 1 pi. And then the ones that are vertical are the halves, right? So as I'm going around from here, I have a 0 pi, then a 1 pi, then a 2 pi over 2, and then a 3 pi over 2, right? And then I'm going to move over to the next ones, and I'm going to start using those next. So the next ones might be, let's do the pi over 4s, right? So I know this is 1/4. 2/4 would have fit here, but remember, it's going to reduce down to pi over 2. 3/4 is over here, so that's the line I would use if I was trying to do a fourth reference angle. Then this one would be 4 over 4, which would reduce. And then this one would be 5 over 4, 6 over 4, which reduces, 7 over 4. Okay, so let me switch those. We'll highlight those a little bit. So our 4s are right here, here, and here. All right, so then the next one is, maybe we'll go and do the thirds next, right? So we know 1/3 would be right about here. 2/3 would be right about here. 3/3 again reduces to 1. 4/3 would be right about here. 5/3 right about here, and 6/3 back to 2 again. So highlighting those, we're looking at this one all the way down to this side, this one all the way down to this side. Again, if I were trying to draw a reference triangle with a pi over 3 as its central angle, that would be the line I use with the horizontal line. All right, and then the last one were with the pi's over 6s, right? And the pi's over 6s would be right here. That's 1/6. This was where the 2/6 was, right? It reduces to 1/3. 3/6 would have been up at the top. Here's 4/6, it's already been used, reduces down to 2/3. 5/6 would be right here, we're going to use this one. 6/6 already been used. 7/6 is right here. 8/6 is here, but it reduces to 4/3. 9/6 is right here, but it reduces to 3/2. 10/6 right here, but it reduces to 5/3. And 11/6 is right here. And then 12/6 ends up over here again. So here are our thirds. Cool. So that would be all of the main numbers. So all those 3 colors, the green, the kind of reddish, and the bluish, would be ones that would create reference triangles within those different quadrants. All right, that's it.